Hello and welcome to the ICSE Class 10 Maths tutorial. The topic is Matrices Part 2. So before we start, आइए आपको एक शायर की कुछ लाइन सुनाता हूँ. शायर कहता है, वो कुछ सुनता तो मैं कहता, वो कुछ सुनता तो मैं कहता, मुझे कुछ और कहना था. वो कुछ सुनता तो मैं कहता, मुझे कुछ और कहना था. वो पल भर को जो रुक जाता, मुझे कुछ और कहना था. वो पल भर को जो रुक जाता, मुझे कुछ और कहना था. गलत फहमी ने बातों को बढ़ा डाला यूं ही वरना, गलत फहमी ने बातों को बढ़ा डाला यूं ही वरना. कहा कुछ था वो कुछ समझा, मुझे कुछ और कहना था. कहा कुछ था वो कुछ समझा, मुझे कुछ और कहना था. और एक और शेर मुलाहिजा फरमाएं. शायर कहता है, पत्ता पत्ता बूटा बूटा हाल हमारा जाने है. पत्ता पत्ता बूटा बूटा हाल हमारा जाने है. जाने न जाने गुल ही न जाने, बाग तो सारा जाने है. जाने न जाने गुल ही न जाने, बाग तो सारा जाने है. थैंक यू. Okay, so in part 1 I have explained some basic things like the definition of a matrix, the order of a matrix, etc., etc. In part 2 here, we are going to discuss these terms: column matrix, row matrix, etc. What is a column matrix? A matrix in which there is only one column is called a column matrix. For example, 1, 4, 3. There is only one column matrix. Another example, 4, 6. There is only one column, so it is called a column matrix. The order is here. There are 2 rows and 1 column, so the order is 2 by 1. Here the order is 3 by 1 because there are 3 rows and 1 column. And once again I am telling you, we don't have matrices of order 3 by 3 in our ICSE syllabus for class 10. Okay, so this is column matrix. Now what is a row matrix? In a row matrix there is only one row. There is only one row. There is only one row. For example, 1, 2. There is only one row. Row is 1. There are 2 columns, but row is 1. Another example you can take. 4, 5, 7. Row is 1. Though there are 3 columns. 1, 2, and 3 columns. 3 columns or 3 rows I am taking only to explain to you what is a row matrix, what is a column matrix. Otherwise we don't have 3 by 3 matrices. Once again I am telling you. So this is a row matrix. Why? Because there is only one row. Of course there are 2 columns. This is again a row matrix. Why? Because there is only one row, though there are 3 columns. 1, 2, and 3 columns. Alright. After that we have a square matrix. A square matrix, as the name itself tells you, that the number of rows and the number of columns should be the same. For example, so square matrix example is 1, -1, 4, 6. How many rows are there? 1, 2. There are 2 rows. 1 and 2, there are 2 columns. So 2 rows and 2 columns. So it is a square matrix. A square matrix. If I take order 3, then we can write it like this: 1 0 minus 1 0 1 6 3 2 4. Alright? How many rows are there? 1 2 3 rows are there. And how many columns are there? 1 2 3 columns are there. So this is these are the examples of a square matrix. These are the examples of square matrices. This is one square matrix. This is another square matrix. Here the order is 2 by 2. 2 rows and 2 columns. Here the order is 3 by 3 because there are 3 rows and 3 columns. Fine. Okay. After that, we talk about diagonal matrix. These are the elements. These are the elements which are forming the diagonals of a square matrix. If Aij is a square matrix, then if square matrix we are talking about, no. So this will help you in higher classes also, these concepts. When you study matrices at college level, 11th and 12th, in 12th standard, then this basic idea, this concept will help you there also. What is the diagonals? If you have a matrix, suppose A, you have a matrix A, and like we write Aij, we write like this: Aij, where Aij Aij. This is a square matrix. A is the matrix. The element are written general Aij, where I is the row and J is the column. You can give different values to I and J, and then you can write down the matrix. So if A is a square matrix, then the elements A11, A22 and A33, they constitute the diagonal elements. They are the diagonal elements. Got it? A11, A22, A33, they constitute the diagonal elements. What does it mean? A11. A11 means element in the first row and first column. Element in the second row and second column. Element in the third row and third column. For example, see here. This first row and this first column. So this one is A11. This is the element A11. Element in the first row and first column. So A11 is 1 here. Similarly, this is in the second row and second column. So A22 is here 6 in this case. A22 is 6. Now come here. A11 is 1, first row and first column. This is second row and this is second column. So this is A11, first row, first column. This is A22. A22 because this is second row and this is second column. So this is A22. Alright, if you are confused with 2 times, then you can change it. Let me write down some other element. Alright, so I am writing suppose 9 here. I am writing 9 here. Alright, so A11 is 1 in this case. A22 means second row and second column is 9. So A22 is 9. A33 is 4. Alright. So these are the elements which form diagonal. So this is called diagonal. Please be clear. And not this one. This is called diagonal, leading diagonal. Alright, in a square matrix. This is diagonal. this is diagonal. This is diagonal. Got it? Similarly, this is diagonal, and they are the diagonal elements. Alright. So diagonal is clear now. Now we are going to discuss a diagonal matrix. So a matrix in which all the, so if this is diagonal and if 1, 9 and 4 they are the diagonal elements, then these elements, they are non-diagonal elements. So in a matrix, if the non-diagonal elements are 0, in a matrix, if the non-diagonal elements are 0, so this is also 0, this is also 0, this is 0. So what can you say here? You can see that all the non-diagonal elements are 0, you have only diagonal elements. Alright, you have only diagonal elements. Such a square matrix is called a diagonal matrix. Please understand. This will help you in higher classes also. As I told you earlier, that when you are in college, 12th standard, we have the matrices and determinants. So this concept will help you. At least you are familiar with this. So diagonal matrix. What is a diagonal matrix? I square matrix. Please remember, not any matrix. I square matrix. Now I square matrix, you know. So I square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. Fine. I hope clear. After that we come to a scalar matrix. Scalar matrix. Now see how they are related to one another. Now diagonal matrix is clear. This is diagonal matrix. Now in this diagonal matrix, if all the diagonal elements are same, suppose this is 4, this is 4, this is 4, right? If all the diagonal elements are same, then we call it a scalar matrix. That means a scalar matrix is a diagonal matrix. You can define a scalar matrix in terms of diagonal matrix or in terms of a square matrix. So if you are defining a scalar matrix in terms of diagonal matrix, what will you say? You will say that a scalar matrix is a diagonal matrix in which all the diagonal elements are same. Because if the diagonal elements are not same, then it will be a diagonal matrix. And in a diagonal matrix, if all the elements are same, these diagonal elements are same, then we call it a scalar matrix. I like a scalar matrix. So a diagonal matrix becomes a scalar matrix if all the diagonal elements are same. Fine. And if you want to define a scalar matrix in terms of square matrix, then you will say like this. A scalar matrix is a square matrix in which all the non-diagonal elements are 0 and the diagonal elements are same. Because we are defining now in terms of a square matrix, so you will have to say that the non-diagonal elements are 0. And when you are defining in terms of diagonal matrix, so then you need not say that the non-diagonal elements are 0, because diagonal matrix means that the non-diagonal element should be 0. Are you getting? Fine. So that is a scalar. So this is a scalar matrix. Now it is a square matrix in which all the non-diagonal elements are 0 and the diagonal elements are same. Fine. After that we come to unit matrix. Now see the similarity. Now this scalar matrix becomes a unit matrix or an identity matrix if not only they are same, but each element is 1. They have to be not only same but 1, unity, 1. So they are same also and at the same time 1. Alright, now it becomes a unit matrix or identity matrix. Alright, unit matrix or identity matrix. So you can define unit matrix in terms of a scalar matrix, or in terms of a diagonal matrix, or in terms of a square matrix. If you are defining a unit matrix or an identity matrix in terms of a square matrix, then you will say that a unit matrix is a square matrix in which all the non-diagonal elements are 0 and each diagonal element is 1. Fine. And if you are defining unit matrix in terms of a scalar matrix, then you will say that unit matrix or identity matrix is a scalar matrix in which each diagonal element is 1. When we say scalar matrix, then it is understood, it goes without saying that the elements are same, then only it is a scalar matrix. So a unit matrix is a scalar matrix, that means all the elements are same, because we are saying scalar matrix. So a unit matrix is a scalar matrix in which each diagonal element is 1. Alright, so that is the identity matrix, and we write the symbol is capital I. Capital I. If we write I2, that means we are talking about an identity matrix of order 2 by 2. If we write I3, that means we are talking about an identity matrix or unit matrix of order 3 by 3. You need not write on 2 by 2. Only if you write I2, that means it is understood. It's the order of this identity matrix is 2 means 2 by 2. That means 2 rows and 2 columns. In some cases, in which context you are writing I, you need not even write down this. Sometimes no, you see the context. If all the matrices are suppose 2 by 2 matrices, and then you are adding one identity matrix, so it is bound to be a 2 by 2 matrix, because I'll tell you in my next video the addition of 2 matrices when their orders are same. So then it is understood that, okay, because A is of order 2 by 2, B is of order 2 by 2, and we are adding I in that, so the order of I should also be 2 by 2. Alright, but we generally write down I2, I3, something like that. Okay, I2. That is unit matrix or identity matrix. After that, we come to null matrix. Now till here, see, from square to unit matrix, they all are a square matrix. Null matrix need not be a square matrix. Please be clear about it. There shouldn't be any confusion between an identity matrix and a null matrix or zero matrix. Alright, fine. So a zero matrix, now I'm telling you what is zero matrix or a null matrix. So that means a null matrix may be a rectangular matrix also. This is a null matrix, and we use the symbol O. Alright, O. This is a null matrix. 0, 0. Is it a square matrix? No, because there is 1 row and 2 columns. Another example. 0, 0, 0. This is a square matrix. At the same time, a null matrix. Got it? A null matrix or a zero matrix. I have written null matrix, we call it zero matrix also. This is a square matrix. This is not a square matrix because there is 1 row and 2 columns. What I mean to tell you is a null matrix or a zero matrix need not be a square matrix. Alright? So things are very, very clear, and they are important not only for ICSE 10 standard or any board 10 standard class where we are starting matrices, but also for the higher classes, because when you know all these things, then you find it very interesting, because the basics, the fundamentals, you know. Okay then, thank you so much. Thanks.